Hi guys, I'm going to do the first lesson of our new topic, factoring. How do we factor expressions using the difference of two perfect squares? So try the do now first. Multiply the binomials x plus 3 times x minus 3. Okay, now I'm going to do it. It's multiplying two binomials, so I set up the box, and when I square x, then negative 3 times x, then 3 times x, then 3 times negative 3. When I simplify, those middle two terms are going to give me a sum of 0. So our final answer is going to be x squared and then just the minus 9. There's no middle term. So this was our special case. Does anybody remember what it was called? When we multiplied two binomials like this, that our product was a binomial instead of the usual trinomial. Anybody remember that these were called conjugates? They have the same two terms, but the middle sign is different. So your answer to the do now is an example of the difference of two perfect squares. We will now go backwards and start with the difference of two squares to find the factors that were multiplied to get to it. So first I want to explain why it's called a difference of two squares. Both terms must be a perfect square, and there must be a minus sign between them. That's why it's a difference. If there's a plus sign between the two terms, they would not be a difference of two perfect squares. So every example is going to look like this one, where we have two perfect squares. So let's actually first review perfect squares. Okay, you guys should have a note card on perfect squares. If not, you could make one. Actually, that reminds me, we'll make a note card on factoring the difference of two perfect squares after this. I keep adding the word perfect in here. We don't usually say that though, because difference of two squares is just DOTS, dots, but I'm used to calling them perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and so on. So when I want to start with the binomial, like here, x squared minus 100, first I check, is it a difference? Yes, there's a minus sign. Is it two perfect squares? X squared is a perfect square. 100 is a perfect square because what number times itself will give you 100? That's right, 10. So if I take the square root of x squared, I'll get x. If I take the square root of 100, I'll get 10. Therefore, my two factors are going to be conjugates, so I know one of them is going to have a plus and one of them is going to have a minus. Then my two answers over here, when I got the square roots, x and 10, are going to be the first and second number in each parenthesis. X first in each, 10 second in each. It doesn't matter if you switch the plus or minus sign, so I could also rewrite this as x minus 10 times x plus 10, and those are equivalent answers. However, the x has to be first in each binomial, and the 10 has to be second. The plus and minus sign, it does not matter. So we're going to do a few examples together right now. Then I'm going to assign a homework problem sheet, and then you guys could complete that on your own. And next period, you guys could check that homework. So here, I'm going to put scrap work next to each problem. Here, I first check in my first example, is this a difference of two perfect squares? I have the minus sign, I have x squared and 16, both perfect squares. Meanwhile, you like my new tool in Notability? I'm kind of into that. So I have the square root of x squared is x. The square root of 16 is 4. So I set up my two binomial factors. I have x goes first in each, plus 4 and minus 4. So how could I check now that this answer is correct? Not that you have to check, but how could I check that this is the same? Well, one thing you could do is multiply out x plus 4, x minus 4. Set up a box and multiply it out like we did in the do now, and your answer would be x squared minus 16 if you factored correctly. Another way to check, let's see if I could get my calculator on my screen. I got to clear this out. Okay. I'll first do the x squared minus 16 graph. And do you guys see the graph of x squared minus 16? Now my answer was x plus 4 and, oops, I forgot to press the arrow to get out of that parenthesis, x minus 4. And when I graph that expression, the graph goes right on top of it. So that's another way to check that x minus 4 times x plus 4 is equal to x squared minus 16. While we're on the calculator, let's also see that if I put the x minus 4 first and then put the x plus 4 second, it would also be equivalent. That graph goes right on top. However, if I change the order of the 4 and the x, so 4 minus x, and then put 4 plus x second, not the same. So the order of the signs, I could put the plus or the minus in either. I'm deleting that last one because it's not equivalent. But you have to have x first in each parenthesis and 4 second. The plus or minus doesn't matter. Back to the lesson. How am I doing, guys, on my first screen recording? Not to say I won't edit it before. I don't know if I can edit. Okay, square root of 121, and then the square root of x squared. Also, always check that there's a minus sign between them. The square root of 121, what number times itself is 121? 11. The square root of x squared is x. So I have x plus 11 plus x, and then 11 minus x. When the number comes first in the binomial, the number is going to be first in each of the binomial factors. Again, they're conjugate factors, x plus 11, x minus 11. You can multiply them like we did in the do now to check that they are equivalent to the expression we started with, or you can graph them both in the calculator. Graph the original expression and our new expression, and the graph should be right on top of each other. Pause for a couple minutes so that you could check the next, you guys could try the next two on your own. Putting a timer so I give you enough time. I'm still here waiting for you guys to check. Okay, finish up, and I'll go over these last two before moving on to one more concept. Okay, we have the square root of 4x squared and the square root of 1. Make sure it's a minus sign between, which it is. Square root of 4x squared is 2x. The square root of 1 is 1. So I'm going to set up my two parentheses for my binomial factors and have 2x plus 1 and 2x minus 1. My final example, again, is a minus between two perfect squares. The square root of 16x squared is 4x. The square root of 49y squared is 7y. Set up my two binomial factors. 4x goes first in each, 7y goes second in each, and I'll put a plus and a minus. Okay? Now we're just going to look at a few other examples where the power could potentially be over 2. For instance, x to the 10th power is a perfect square because there's powers that you can multiply by itself to get x to the 10th. So looking at this right here, I'm going to fill this in. What times itself will give you x to the 10th? The square root of x to the 10th is x to the 5th, because x to the 5th times x to the 5th is x to the 10th. So anytime you have a power, I'm going to write about perfect square powers. Perfect square powers are any base where the exponent is even. And you get the square root by the base staying the same. Divide exponent by 2. Shh.
I gotta go get some more pencils.
Okay, so here we'll do a few now where we have perfect squares with minus signs between them that could be factored using this method, but now the powers are higher than 2. But notice they're all even. 4, 4, 6, 18, 6, 2, 4, 8, 6. All the exponents have to be even in order for them to be perfect squares. So to do the first one, I'll take the square root of x to the 4th, get x, half of 4 is 2, and the square root of 4, which is 2. And then I have x squared first in each parenthesis, 2 second in each parenthesis, plus and minus. In my next example, I'm going across. I have a to the 4th. Square root of a to the 4th is a squared. Square root of b to the 6th is b to the 3rd. Set up my two binomial factors. A squared goes first in each parenthesis. B cubed goes second. Plus and minus. Next example. Square root of 81 is 9. Square root of x to the 18th, the base stays the same. Half of 18 is 9. So I set up my two binomial factors. 9 goes first in each parenthesis. Plus x to the 9th and minus x to the 9th goes second. Next example. I have x to the 6th and 25, so I'll get the square root of each of them. Set up my binomial factors. X cubed goes first in each. 5 goes second in each, plus and minus. Next example. Square root of 36x squared y to the 4th is 6xy squared. The square root of z to the 8th is z to the 4th. Set up my two binomials. 6xy squared is first in each parenthesis. Z to the 4th is second in each parenthesis, plus and minus. And my last example, I'm going to get the square root of 81x to the 6th, which is 9x cubed, the square root of 1, which is 1, and then set up my two binomial factors, 9x cubed, plus 1, and minus 1. So now, for those of you who want to keep your flip books going, because I think they'll still be a good tool for you, I don't remember what number we're up to in the flip books, but this will be factoring dots. Okay? Inside the card, write must be perfect squares, must be subtraction. Now, maybe make a list of your perfect squares. So numerical, your perfect squares are 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on. You could keep writing more. Perfect square powers. X to the second, x to the fourth, x to the sixth, x to the eighth. Any x to an even exponent. And I would put an example from the first set of problems and from the second set of problems. Boys and girls, this has been my first recording. Now, next period that you have me, whether it's next period today or next period tomorrow, do the homework sheet. And then I'll have a lesson like this, or I'll have an answer key with all the answers. Check your answers, and then contact me if you have any questions. Then the following lesson will be another method of factoring. Guys, I miss you and hope this went okay.